Hi guys, welcome back here at the EC Engineering tutorial. So this time is we're going to talk about the basic soil-water relation. So again, this is part of uh, lecture in irrigation engineering. Okay, so yung first nating i-discuss is why is it important, no? Na alam natin yung soil-water relation. Okay? So dry land and irrigated agriculture depend on the management of two basic natural resources such as soil and water. So soil is the supporting structure of plant life, and water is essential to sustain the plant life. So the wise use of these resources requires a basic understanding of soil and water as well as the crop. So let's talk about the physical properties. So the term soil refers to the withered and fragmented outer layer of Earth's terrestrial surfaces. Now, fragmenting and withering, which breaks down the parent material to form a soil, are the result of both physical and chemical processes. So erosion, both wind and water is the most visible soil creating process. So makikita natin dito, ito yung soil natin. So meron siyang soil particle. So meron din siyang water. And yung makikita nyo dito parang white colored na yan. Yan yung air, no? So andito din yung crop natin, no? Yung root crop. Okay. So a given volume of soil consists of apat na parts, no? We have the matter, mineral matter, the organic matter, the water and air. So the mineral and the organic matter of soil store nutrients required for the crop. So dito yung mga nutrients, no? And the relative amount of mineral and organic matter determine the physical properties of soil. So the remaining volume of soil composed of spaces between the mineral and organic matter, which we call it pore spaces. No? Itong air and water, yan yung pore spaces natin. And it is filled with varying amounts of water and air. So bali yung mineral takes about 45% and organic is 5%. So bali yung total nung solid particle is 50%, while yung sa pore pressure natin takes up water, which is 25%, and also air, which is 25%, a total of 50%. No? So bali yung soil natin is 100% lahat. Okay, so yun yung solid or yung solid particle natin. And ito naman yung pore spaces natin. Okay, so ayan, no? And so dito sa solid, meron tayong mineral which is 45% or organic. And then dito yung air at saka water, ito yung mga pore spaces natin or voids. So all in all, ito yung soil composition natin. So soil particles may be classified as sand, silt, or clay depending on their sizes. Okay, so coarse soils such as sand and gravels have relatively large pores. However, the number of pores is small when compared to a finer soil, no? Where finer soils such as clay and clay loams have relatively small pores, but marami siya, no? So the small but abundant pores allow finer soil to hold more water. Okay, so with regards naman sa soil texture, it is classified on the basis of the distribution of the sizes of the individual particles. Okay, so it is determined by the relative amounts of the three groups of soil particle or yung tinatawag natin na soil separates. The three soil separates are sand, silt, and clay. So texture provides a means to physically describe soil by feel or by measuring the proportion or the percentage of the three soil particle sizes. size ranges. So a coarse soil has a relatively large amount of sand and feels gritty, while a silt soil has the texture and feel of flour, and a clay soil may feel slick or sticky depending on its water content. So a loam soil has nearly equal amount of sand, silt, and clay. Yan yung loam. So in terms of sizes, makikita natin dito yung comparison nila. So this term refers to the relative proportion of sand, silt, and clay in the soil. So each of these components is defined by its size. So pag sand, around 0.05 to 2 mm. Makikita mo yan dito, 2 mm. So malaki na siya, no? Pero itong silt is mas maliit, no? Around 0.05 to 0.002 mm. So ito yun, no? Yung clay yung pinakamaliit, no? Less than 0.002 millimeters. So the soil texture is more correctly referred to as the soil particle size distribution. So sand particles can be seen by the naked eye, and a microscope must be used to see the silt particles, and electron microscope is needed to see the clay particles. Kasi sobrang late nila. No? So, ito yung name ng mga soil separate natin. We have clay, silt, fine sand, medium sand, coarse sand, and very coarse sand. So, with this soil separate, meron din siyang mga corresponding diameter limits in millimeter in accordance with the United States Department of Agriculture classification. So, for clay, that is less than 0.02. Pag silt, 0.02 to 0.05, di ba? And then, pag sand, makikita mo, ranges from around 0.05 to 2 mm. Okay? So, ito yung sand. So, to determine the soil texture, a sample of soil is oven-dried, wetted, crushed, and passed through a set of sieves of particle mesh sizes. So the amount of material retained by each sieve is weighted. So silt and clay are the fines. Both pass the smallest sieve and are collected in a tray and are separated from each other in a different way. So the sand and coarse fraction are weighted and recorded as a percentage of the initial weight. So the proportion of silt and clay are measured during a hydrometer test. So a hydrometer is a simple floating apparatus that measures the liquid density. So if the silt and clay are thoroughly mixed with water in a measuring cylinder and then allowed to stand, the silt particles, being heavier, will gradually sink to the bottom while the clay particle will remain in suspension. So after a certain time of settlement, the hydrometer is used to measure the density of the liquid, which is a measure of the amount of clay in suspension and therefore of the clay content of the soil sample. So what is left must be the percentage of the silt. So a textural triangle is used to describe the soil texture. So ito yun, no? Ito yung textural triangle natin or the USDA Triangular Textural Classification Chart. So the three sides of the triangle represents the percentage of sand. We have clay and silt, no? So bali naka-percentage to from 10 to 100%, 10 to 100%, and 10 to 100%. So the intersection of points of the three lines from each side of the triangle determine how the soil texture will be classified. So for example, no? So makikita natin dito na if yung soil natin has 20% clay, so ito yan, no? Ito yung 20% clay. And then 40% sand, so 40% sand, ito yan. And then 40% silt, so ito bali yan. So yung intersection nila, yan yung soil texture niya, which is yung loam. Ayan. So this method is based on the following limit of particle size, that the sand is around 2 to 0.05 mm in diameter. The silt is around 0.05 to 0.002 mm in diameter. And yung clay size is less than 0.002 mm in diameter. So another example is if the given is clay which is 35% gravel, so we have 35%, so clay is 35%, ito yun, no? In between ng 30 and 40, so we have this one. Yung gravel is 40%, tika lang, clay 35%, 40% silt, ito pala yan, 40% ang silt, so ito yan, ito yung 40%, and then 26% yung silt and clay, silt and clay. I think may error to. It must be sand, kasi dito sa figure makikita natin 35% yung clay, and then dito is 40% yung silt, and then dito is 26% yung sand. I think I made an typo error here. Anyway, yun na yun, So, kung 35% clay, 40% silt, and 26% sand, so meaning that is a clay loam in accordance with USDA. Another example is from the percentage of the sand, silt, and clay, determine the soil classification using the USDA. So, bali yung sand natin is 12.5%. So, ito yun. Yung silt natin is 37.5%. So, approximately ito yun. And then, yung clay natin is 50%. So, approximately ito yun. So, meaning, yung soil texture is a clay. So, soil texture has an important part to play in the behavior of soil water. So, the arrangement of soil particles also determines the arrangement of the spaces between the soil particle and the pore space. So, the pore space is where the soil, water, and air are contained. So, large pore spaces drain more readily than small pores. So, small pores hold water more tightly because the surface tension of the water film in the pore is more able to resist the force of gravity, trying to move the water downward through the profile. So, yan, napaka-importante nung soil texture in the design of irrigation system. So, with regards naman sa soil structure, that is just the arrangement ng mga soil particle natin. So, for example, dito, meron tayong soil particle. So, combination with that, combination of soil particle and organic matter, we call it soil aggregate. So, combination of mga soil aggregates, we call it soil structure. So, soil structure refers to the way the soil particles are aggregated together to form a crumbs, a block, or a clads. So, soil structure depends partly on the soil texture, but also on other factors such as the amount of organic matter in the soil, the population and the activity of soil organisms such as earthworms, cultivation practice, even the way rain or spray irrigation droplets impact on the soil surface. So these factors are related to the management and are variable over time. Okay, so soil structure can therefore be short-term, temporary property of soil, whereas soil texture is permanent. Okay, so maraming factor yung soil structure, So probably magiging ganito siya dahil sa mga earthworms, or dahil binubungkal yung lupa, Ito yung kaya dito it can be short term or temporary property lang ng soil. Pero yung soil texture talaga is permanent yan. Okay? Kasi sa soil na yun So the soil structure refers to the arrangement and organization of soil separates or individual soil particles into units called soil aggregates. So the arrangement of soil aggregates gives soil its structure. So there are three broad categories of soil structure. We have the single grain, massive, and aggregated. So generally, the most desirable structures for plant growth is aggregated. Okay, so especially in the critical early stages of germination and seedling establishment. Uh, the principal types of soil aggregates are flatty, prismatic, columnar, blocky, and granular. So ito yun, no? Ito yung itsura ng granular, flatty. Yung blocky naman, meron tayong subangular and angular. And we have this columnar and prismatic. So, ito yun, no? Ito yung itsura ng granular. Realistic view for a while. So, ito naman yung itsura ng prismatic. Ito naman yung itsura ng columnar. Yung blocky, ito yan. At saka yung flatty, ito yan. Okay? So, the process that forms aggregates are wetting and drying, pressing and towing, decaying organic matter, activity of roots, small animals, and bacteria, and also the soil tillage. So, the wetting or drying and the pressing and towing action, as well as the root and animal activity, push particles back and forth to form granules. So, decaying plant residues and bacterial slimes coat these granules and bind them together to form in aggregates. And tillage can expose soil near the surface to the destructive forces of erosion. Okay, so yun yung mga process uh, that form an aggregates. So we have also the particle density. So a soil physical properties are expressed numerically by the following characteristic. We have the particle density, the bulk density, and the pore space or porosity. So if we say particle density, it is the weight of a given soil particle per unit volume. No? In other words, it is the weight of the soil particle or separate divided by the volume of that soil particle or separate. So in most mineral soils like those found in Nebraska, the average particle density is between 2.6 and 2.7 grams per cc. So by contrast, yung organic matter typically has a particle density of about 0.8 gram per cc, while yung water by definition has a density of 1 gram per cc. So yung bulk density naman, it is defined as the weight per unit volume of a soil. So unit volume of a soil includes both those solid and the pore spaces, bali yung parang volume total niya na. So yung bulk density is important because it reflects the porosity of a soil. So loose porous soil have lesser bulk density than tight and compacted soil. So the bulk density of a soil increases with compaction. So bulk density indicates how easily a soil will till, how easily water will infiltrate, and how it will hold water and its suitability for growing plants. Okay? So ganun yung importansya ng bulk density dito sa irrigation engineering. So typical soil bulk density for fine sand, silt loam, and silty clay loams are 1.5, 1.35, and 1.25 grams per cc respectively. So stable soil aggregates are important in the soil because they help maintain the good soil structure. So good soil structure translate into low na bulk density. So as much as possible, yun yung gusto natin, no? Kung irrigation yung pagbabasihan, ha? So 1.3 to 1.5. So if an aggregate is crushed, its bulk density increases and the pore spaces decreases. So high bulk density such as greater than 1.6 gram per cc can result from compaction. So compaction can result from tilling soil when it is wet, no? So like parang may dumadaan na sasakyan, mga yung sasakyan na pang agricultural. So during rains. Syempre, nako-compact din yung soil niya eh. So, as a rule of thumb, yung bulk density greater than 1.7 to 1.8 gram per cc impede root penetration. So, we don't, in an irrigation, di natin gustong dumating dito, no? Kasi di makaya i-penetrate nung gamot, nung ugat nung tanim nung plant, no? Yung lupa kasi sobrang compact eh. So, as much as possible, bughag lang siya, no? Like, low bulk density. So, yung mga bulk density values of various soil types in accordance with USDA SCS. So, ito yung mga soil texture natin and ito yung mga equivalent na bulk density in gram per cc. So, ito yung mga as much as possible, mga andito lang, no? Andito lang, no? Sa fine sandy loam, loamy soil, silty loam, silty clay loam, sandy clay loam, and clay soil as much as possible. Less than 1.6, no? So we have also the soil porosity. So the space between the soil particles is called pore spaces, and this pore spaces contains varying amount of water and air. So soil porosity depends on the soil texture and structure. So soil with lesser bulk density, meaning meron siyang marami siyang porosity, no? Yung mga voids ba, no? So good porosity is essential to adequate soil aeration, water drainage, and root penetration. Okay? So, yun din yung impact ng porosity sa irrigation engineering. So, silty and clay soil have smaller pores but uh, many more pores than a sandy soil. So, water can be held tighter in small pores than in large pores. And that's because of surface tension. Okay, so for this reason, a clay loam with its many small pores can hold more water than a sand. No? So even though the individual soil particles and pores are larger in sand, the porosity or the total pore volume is less in sand than in silty or clay soil. So this characteristic causes the bulk density to be greater for sand. So I think that's it, no? So in the next video, we will be talking about the weight volume relationship that can be used in irrigation engineering. Thank you.